Hello, so we're back, and this time we have a nice laptop to repair. Dell XPS i7 Gen. Now let's check the customer email, and here comes the funny part. Now the email is on my language, yes, I will translate for you. So the customer is saying, "Hi Sorin, Dell XPS a while ago start having backlight issue. Then the customer resoldered the screen connector. It works for about 2 months, and start having same problems again with the backlight. Then the customer is saying, I want to send the laptop to be professional repaired. Then the customer is saying, please record the video. I'm watching your channel. I'm a fan of your YouTube channel and electronics. Now, this is funny, someone who knows me, who watch my YouTube channel, is asking me the laptop to be repaired professionally. Well, I will say the best I can do is a Dodgy repair. Huh? That's a good offer. You still get your laptop repaired, you know what I mean? Okay, let's plug a charger and check the laptop. Okay, plug in the charger. And the meter is coming on with 19 volts, which is good. Pressing the power button. We do have the light here. Okay, we had the light. It's taking like 900 milliamps. And I can't see any picture on the screen. Caps lock, it's working. Okay, so clearly we have some screen issue, you see? Caps lock, it's working. That means the system is not like frozen. I will say, let's open the laptop and check the screen connector. Okay, so the laptop is open. I can clearly see someone work here. Let's unplug the battery. And let's have a look at the screen connector. What do you think? We took this thingy out. Let's go under the microscope and check together. Okay, that's the screen connector. And the connector is out. You know what? Actually, I think the customer problem is not the connector. I mean, every pin is full of flux. Check there, yeah? Not sure if you can see, but every pin has flux on it. Rosin flux. I mean, rosin flux is good, but not on the pins. More than that, the pins are not moving. Look, are stuck with rosin. Huh? The solders, you know what, the solders are fine. I can see the pins are soldered, and it's nothing for me what I can solder here. I mean, all I can do here is clean the connector. That's all what I can do. So let's try to get the rosin out. With alcohol, I will get a tissue so we can clean the toothbrush. And let's clean it. Let's be sure the pins are moving freely and see what will happen. Good. So that's how you get the rosin out. I have the tissue here, and I'm cleaning the brush from time to time, because we have to extract all the rosin from this connector. Yeah, so the pins, check that, the pins are moving freely. You can see every pin. Hopefully you can see that. Good. Now let's clean this connector. I mean, you know what, the rosin is a very good isolator. Very good. and the connector is soldered properly. The only problem was the job was not cleaned. So now if we are plugging the connector, what will happen? The connector is plugged. Let's see. Plug in the battery. Plug in the charger. And probably, no, we don't have to wait because the board has a BIOS battery, yeah? So the laptop should start straight away. It is coming on. 1.1 amp, 1 amp, and still no picture on the screen. So I don't think this is a backlight issue. Well, anyway, if it's a backlight issue, it's not here on the screen connector. So how the laptop worked for like 2 months? That's my question. Power off, power on again. Yeah, the heatsink is hot, but still no picture on the screen. Let me clean the screen to see if we have like a picture at least. In order to see the picture, the screen has to be properly cleaned. Yeah, I can see picture there. Not sure if you can see it. Yeah, you can see it. You can see it. Here, you can see the picture. Yes, indeed, this laptop has a backlight issue. Good. The next step, let's disconnect the screen. And we are looking for the backlight voltage, yeah? Where the backlight voltage is supposed to be. So here is no ground. I'm assuming here is the 3.3. Then the backlight can be this one. You know what I will do? I will stick the probe on the main power rail. Main power rail plus. I'm assuming it's here. I'm only assuming. Let's see if it's beeping here. Yeah, it's beeping. 0 ohms. No, it's not 0 ohms. Lol. Okay, my fault. Okay, let's try to find another power supply. This one. So clearly the plus is here. Yeah, the input. Let's beep the connector. It's not beeping. No, it's not beeping. I don't think we have backlight voltage. Where is supposed to be the backlight voltage? You know what? This connector is confusing. I mean, if this is the backlight voltage, we have only one pin, which I never seen on a laptop, like the plus track to be on one pin. Here is the 3.3 100% because we have this chip, you remember? And basically the way how you bypass this 3.3 switch is a 3.3 switch. You take the chip out and you solder this pin with this pin together. And on that way you bypass the 3.3. But we have pictures, so this chip is not our issue. Our problem is the backlight. Okay, let's say you are confused exactly like me and you don't know where is the plus of the backlight. We can figure it out probably from the wires. So here are data lines, you can see, are all shielded. Okay, take my words back. You can't figure it out from the wires. Too many wires here. Okay, we are looking for pins together. Let's see. No, are not together. Are not together. No, not together. These are not together clearly. Wait a second. This is a OLED screen. Because if it's a OLED screen and we are looking for backlight voltage, it's kind of a different story. Okay, before we are looking for something else, yeah? This one is good. This one is good. This one is good. Good. I'm just checking the tracks, yeah? The tracks are fine. The data lines look dodgy, but they are fine because we have picture. So you see now I'm confused because I don't know if it's a OLED screen or not. Okay, let me plug the battery. Good. And let me power on the laptop. Pressing the power button and let's check the voltages there. So the voltage here is 0. Oh lol. Yeah, you know why? So here we have nothing, and here we have nothing, which is strange. I don't have ground. 1 second. Yeah, it was my fault. It was no ground. So here we have 0. Lol. 1 second. 0, 0. Yeah, 3.3. So this laptop has a screen detector. Yeah, so if the screen is not plugged, we're not gonna have 3.3 here. Actually, the lead sensor is taking out the power. Let's see. No. No, has a circuit which is detecting the screen if it's plugged or not. Yeah, the laptop is on. Okay, let's plug the screen again. Yeah. Plug in the battery. Pressing the power button, the laptop is coming on, and let's check some voltages. So what do we have on this power rail here? We have 3.3. Here we have 3.3. 3.388. 3.363. 3.393. Here I'm assuming is ground. Yeah. This sucks. Okay, let me try to find a schematic, yeah, just to understand what we are dealing here. Give me 1 minute. I found a schematic. Okay, so that's the screen connector. So here is 3.3. I believe here we have 3.3, but let's check, yeah? Let's go and check according with the schematic. Yeah, here is supposed to be 3.3, 3 VSTS. Then here is touchscreen. Yeah, here it is ground. Good. Then we have LCD GPIO. 2 pins. Yeah, okay. Then we have backlight power here. Then we have inverter power here. Then we have ground here. And yeah, that's ground. Uh, I'm interested to see here. What do we have here? What do we have? Yeah, these two pins. But in any case, we don't have access on this side of the board to anything else regarding the backlight. So I'll plug the connector, but I can't check with the connector, right? I can't check, that's crazy. No, I can't check. Okay, let's try without connector. Okay, so without the connector, here we have 0, and here we have 0. So we have 0 because the screen is not plugged in. Here we have 0, and this is GPIO. How we are fixing this? I mean, remember all my videos was about, oh, fixing backlight is so easy. Well, not on this case. But the inverter, one second, inverter power, PWM, is coming from the EC chip. But what is display off? We have something like that here. No, I can't see. Display off. Okay, but this is not helpful. I still don't understand what is this. This off. I don't have this kind of pin here. I have backlight PWM and I have inverter PWM. You know what? One second. I believe these are like low current kind of data lines. I believe this is equivalent with LED on and PWM on the screens. That's what I believe. I believe here are no power lines. I believe this screen backlight is from LCD VDD, which is 3.3. I think it's 3.3. Yeah, it must be 3.3. LCD VDD. We can find that. LCD VDD is coming from the chip I show you, yeah? The chip which I'm usually take up, no, I'm usually, when the chip is blow up, you remember, I'm taking out the chip, I'm shorting the input with the output, and yeah, we are supplying 3.3 to the screen. So this is the LCD VDD. Yeah, interesting. You see how it's, you have an enable pin and input and output, that's all. So you can easily get rid of this chip, just solder input with output, and that's all. Yeah, okay. So the story is like that, yeah? If we have 3.3 on inverter PWM and backlight PWM, if we have 3.3, means the screen is faulty. If we don't have 3.3, then we are supplying what we promised on the beginning, a dodgy repair. Fair enough? Still, I'm not sure how can I check the pins, because if I put the connector, I don't have access to the pins. So what you'll do in my case, find from where the signals are coming from the EC chip. I mean, we can take the board out, but that's long. You know what I mean? We can find the wires here. I'm pretty sure we can. We can find the wires here. Yeah. Probably that's the best way, right? Yeah, we can. We can. So, we have how many pin number? Pin number 10 and pin number 9. Yeah. So pin number 10 First is ground? No, no way. No, first is not ground. So which is the first pin then? Let's see. Probably the wires are shielded, even those. And check how flexible they are. No, we can't check. I mean, we can, but it will be a pain. No. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the red one. What you'll do in this case, huh? How you'll approach this repair? I can't take the board out because I need a board with, you know, everything connected on it. Nine and 10. These pins. I mean, at this one, I do have a little bit of access. 9, 10, and this one is 11, right? Yeah. Okay, so what I'm gonna do, you won't like it. What I'm gonna do, let me switch to diode. Yeah. I mean, according with the schematic, yeah? Let's go back to the schematic because, you know, being dodgy, it doesn't mean we are going like crazy, like, you know, risking the customer laptop. But according with the schematic, even if I come with 3.3 on these pins, yeah, the 3.3 it will not goes back to the EC chip because we have two diodes. So we can come with 3.3. Yeah, yeah, we can. Yeah, let's do it. I mean, we have no other options. Any other option for me is crazy. I mean, I'm assuming the EC chip is not switching on the screen. That's all what I'm assuming. I can't see a reason why the diodes, these diodes, will get burned. No. Yeah, let's do it. Let's do it. You know, like easy and pleasant job. What do you think? Can we do it? Easy and pleasant. Yeah, I need my pizza. Yeah. So this pin and this pin. Good. That's good. And now a proper calibrated wire. Good. And this wire is going to 3.3, right? Yeah. Here. Perfect, right? Be sure it's not touching anything else. Good. Good. We done it. Let's see. 1 second. If we are plugging the connector, we are not shorting the wire, right? Probably not. No. No, we are fine. We are fine. Good. Now is now, yeah? We have backlight or not? Plug in the battery. Nothing smoke, nothing blow up. We have no backlight. Okay, that's crazy. Yeah, we have picture but no backlight. Nah, I'm sorry. Nah, no, that's a faulty screen. That's a faulty screen. I mean, if we are disconnecting that wire, yeah? If we are disconnecting this wire, we should have 3.3 on this wire. And we can test that, yeah? So let's disconnect the wire and let's check the voltage on that wire. I'm pretty sure we have 3.3, which means it's a screen issue. Good. So we disconnected the wire. Good. Let me power on the laptop. So the laptop is on. And what do we have here on the wire? We have 0. But why? No, check that. We have 1.3, 1.4. Yeah, 1.3, 1.6. It's going up and down, which can be normal. I'm assuming it's because the lead is close. Let me check again. One point three. We don't have 0. We don't have 3.3. Yeah, we do have picture on the screen. Okay, let me do something else. Yeah, let me try something else. To plug in the battery, plug in the charger. Yeah, because with the charger plugged in, it's a different story. And the laptop, it will not save energy and it will push like full brightness on the screen. No, that's what I believe. And we have, check that on the screen, 2.7. You can see we have 3 volts. Yeah, 3 volts we have. No, it's not touching anything here. No, check there, 3 volts. When I'm actually touching the wire, it's going to 3, I'm pretty sure. Three volts, you see? 3 volts. So we do have the voltages for the screen. Okay, that's not a problem with the voltages. The problem is the screen itself. And it's nothing what I can do apart from speaking with the customer, let him know he need a screen. But I'm just, trying to point how you can diagnose this kind of issue. Let's take that wire out. The wire, my proper calibrated wire. I can't believe. Yeah, perfect. Yeah, I'm really sorry I have to stop this video. Can we fix the screen? Probably we can, but how you open the screen? Maybe this is a touch screen. Look at this screen. I mean, you'll take the risk? So this is not like a normal screen. Probably it's OLED. We don't have like high voltage for the inverter. Anyway, you know what I'll do? I'll upload the video. Let me know your opinion if you have experience on something like that. But I believe I checked whatever was, to check. Still, the freaking schematic doesn't make sense. I'm not sure what is this. This off. I'm assuming is this backlight, backlight PWM. Backlight enable EC. And this is PWM. Backlight enable. DBC enable this one? No way. DBC enable. What is DBC enable? DBC. Wait. Bro, 1 second. What is here? What is here? 1 second. This is the. What is this? EDP backlight. What is EDP? Why we have inverter power here? So this is a different connector. Display off. Yeah, but this is JCam. This is the camera connector, right? Backlight power. What is this then? I mean, this is crazy. Don't tell me I work like freaking 53 minutes on a different connector. EDP connector, yeah. EDP backlight. What the freak is that? Feels bad, man. So you want me? You told me actually the backlight connector is a different connector. 1 second. So this is one connector. Yeah. Okay. Wi-Fi, and that's all. Yeah. We have two connectors, but this is the webcam. No, backlight LCD. That's crazy. CCD. BLCCD, sorry, 1 second. Now I'm confused. I'm proper confused. So this is not the camera connector. Hmm. One second. Because now it's making sense. This off is actually going to the other connector. Here. This off. Okay, let's see what this connector is doing. Plug the power on. The laptop is on. Let's see what we have here. So we have this voltage, which is 0, can be ground. We have this voltage, which is 7.2. Lol, we do have the backlight voltage. Feels bad, man. Feels bad. Yeah, inverter power SRC, which is coming from here. This chip here. So we do have the backlight voltage. That sucks. Okay, so we have 7 volts, which is the main power rail. This off. Okay, let's check pin number 10, right? No, this off. Yeah, pin number 10. And backlight. Yeah, pin number 9. Pin number 10 and pin number 9. 3.2. And pin number 9, 0. You know what? I got confused because the customer said he soldered the screen connector and the backlight worked for like 2 months. But obviously, it looks like the backlight have nothing to do with that connector, actually. Probably is the screen is faulty. Not sure if this off has to be on or not. Backlight enable. You know what? I think this has to be on. So if that one has to be on, then pin number 10 has to be 3.3, pin number 9 3.3. So let's check one more time. Pin number 9, 0. And pin number 10, 3.2. Now why this is 0? Has to be 0. Shorting with this pin, and we have 3.2 on both pins. Yeah, let's short this, yeah? Let's short this together. Yeah, let's do it. Let's do it. If they are shorted together, I should have 3.3 on both. That means we should have backlight. These pins together. Good. Just a tiny bridge there. Yeah. Let's check now. Let's see. We have backlight or not. Pressing the power button. No backlight. Lol. Nah. Nah, that's a faulty screen. That's a freaking faulty screen. Well, I'm gonna stop here. I will speak with the customer. I'm gonna stop here. I'll speak with the customer about the laptop. Clearly, need another screen. Nearly to like 100%. The screen is faulty. Yeah. See you on the next one. Bye. Not so quick. Not so quick. Sorin is skipping the promises. So we'll be delivering a Dodgy repair. Now, remember we checked the voltage here? Without the connector, because we can't really check under the metal thingy. And it was like 7 volts, and I assume it's the battery voltage, which is 7.6. But actually, it's 8.4 fully charged. But if the battery is not charged, then 7 point something, what we checked, is a real voltage for the inverter. Good. And I said, you know what? What about, I thought, what about if I plug the connector, something happen? And, you have a short, you have, I don't know. Then I solder a wire on the inverter pin. This is an interesting fault. Trust me, it's worth the time you spend here. So pressing the power button, the laptop it is coming on. Let's check the voltage on that wire. So the voltage on the wire, check on the screen, 4.1. We checked, yeah, 7 point something it was, and now it's 4.1 with the connector plugged in. So with 4.1, probably our inverter is not working how it's supposed to work. And you will say, yeah, that's fine. Just bridge it. Yeah. So what does mean? Does mean if we are coming with power supply, the backlight is working? Let's check. So pressing let me lower the voltage here. On the power supply, 7 volts. Pressing the power button. And plus on the back, check on the screen. Check on the screen. Huh? We have backlight. Huh? So what's the problem? Huh? What is the problem? Clearly, the problem is whatever is supplying power to the backlight, right? Let's have a look on the schematic. So this chip is supplying power to the backlight. Yeah, check here, yeah? So we have the output inverter PWM SRC, which is coming exactly here. You can see it here. So what this is doing is passing the voltage, nothing else. So I found the chip data sheet, and that's the chip. And what the chip is doing, check here, yeah, V in and V out. It's just a MOSFET, yeah. So yeah, you can enable the MOSFET or not. So it's passing the voltage, no boosting, nothing, yeah. So clearly at the output, we should have the voltage from the input. Now, based on what we've seen here, having at the output like 4 volts, and you can see here plus B, that means it's connected to the main power rail. Plus B means whatever voltage is here has to be at the output, yeah, here. So what is the problem? And you will say, sorry, of course, it's a Dodgy chip, this chip. I don't know what is on the board. I couldn't find this chip on the board. Probably it's on the other side of the board, and I'm not going to take the board out. Okay, so what the chip is doing? This chip, what is doing, is just, you know, supplying backlight when it's turning on, when it's turned on. I can't see really the point because the brightness and the screen coming on and off is controlled by the EC chip. But anyway, I'm assuming it's a protection. That's what I'm assuming, and you will see why. So okay, the screen, this chip is not delivering voltage to the inverter, to the screen inverter. So the chip is dodgy, right? Think twice. Think twice. Huh? You have a current sensor here. And you'll say, sorry, it's not a current sensor, it's just a resistor where it's saying 60 milliamps. And we cannot see anything here to read this resistor. But if you check this pin, yeah, inverter PWM SRC in plus, yeah, and we're going to put page 35, which is here. Check here, power monitor. You can see it. So the power monitor is monitoring that resistor using the voltage from the inverter and the voltage from before the resistor. Let's go back. Okay, so you can see here, yeah, one track is going there and the other track is from here, is going from here. So it's monitoring this resistor, the current across the resistor. And you will think, okay, sorry, so if you have 4 volts, it is possible this resistor is burned, or actually the chip is burned. Well, I'm assuming nothing actually is burned here. Nothing. Now, you see here it's saying 60 milliamps, so that's the limit. You can see on the input 60 milliamps, here 60 milliamps. So if the current is going over the 60 milliamps, the system, exactly that chip, it will turn off this switch. This is just a switch, this chip. That's what it's doing. It has a MOSFET inside and it's switching on and off the power to the backlight. Now, what current is taking our screen? Let's see. Let's see one more time. Maybe you didn't spot it on the beginning. Let's see. So coming with the power supply, I have like 7 volts there. Pressing the power button, the laptop is coming on. Let's see. Let's wait for the screen to come on. Check that. Check the current. Check the current. 430 milliamps. Check the current. You can see. So we should have 60 milliamps, but we have 430, which is like so many times over the, you know, over the what is supposed to take. So as you can see here, nothing is faulty, but still is not working. I mean, it is faulty. The screen is taking too much current, and the chip is doing what it's supposed to do. The power monitoring this resistor, seeing like high current, and is switching off this chip. Why the current is high, like 430 milliamps? How we can know? How we can know? We have no idea. Maybe the screen has been replaced with a copy one. Maybe. Not sure. Something wrong with the inverter? Not sure. Not sure. But in order to deliver a working laptop, the only chance we have is to bypass this resistor. I mean, not really bypass, because that means I have to take out the board and find this chip and short this current resistor. No, but we're gonna bridge the B plus with the screen backlight. Okay, Dodgy. I mean, what could possible do you could do on this case? What you'll do? It's easier. You speak with the customer. Yeah, just buy another screen, and yeah. But this screen probably is good. I mean, the screen is good. Clearly, the screen is good. But the backlight is dodgy, and you know, the dodgy backlight. We are delivering a dodgy solution for this. Is nothing more what we can do. I mean, the customer still can use the laptop. So let's bridge this No, we cannot open the screen to see what's wrong there. I don't know. Maybe there are some LEDs which are shorted inside. I don't know. But indeed, it's taking a huge amount of current. I mean, don't get me wrong, like nearly 500, nearly half of amp. It's a lot. Probably something is getting hot. Possible. But we're gonna see that. So we are soldering the wire here. Here is B plus. I checked before. B plus there. And we use a proper calibrated wire for a proper calibrated Dodgy repair. And now if we are plugging the battery, pressing the power button, we have picture, huh? What do you think about that? What do you think about that? I mean, for me, backlight looks really bright. I mean, I will tell you how it looks. Maybe to you the same. So here is looking like very bright, and here I have some shadow on the screen. So it is possible to on the screens to be few LEDs shorted. But the thing is, those LEDs are current controlled. So even if they get shorted, it's not supposed for the current to goes up. So I cannot explain, logically speaking, I cannot explain why this screen is taking 430 milliamps for the backlight. It is getting warm here, but yeah. I mean, it is working, right? It's switching off because it's no hard drive. Let me plug a hard drive and let's check with the Windows. Okay, the SSD is plugged. Let's press the power button. Well, let's check. Yeah, coming on picture. Loading the Windows. And it's working fine. Check that. Yeah, the backlight should work to be adjusted. Yeah, so the backlight is not adjusted using the inverter backlight. Yeah, the picture quality is amazing. No, you can't. Probably there are no driver installs. You cannot adjust the brightness. But I can assure you, have nothing to do with what to repair. And the laptop switched off. The battery died. Okay, let's plug a charger. No, the battery didn't die. But like what? Why switching off if I unplug the charger? One second, from where I get the voltage, the backlight voltage? Let me check. .5. So what can be wrong? Now no one is checking the current, yeah? Let me check one more time. .45, 8.46. Lol, 1 second, this is not 848, 849. This is not B plus. Okay, I think it's my fault. And obviously, if it's not the same voltage, it will be voltage different across that resistor, and it will that chip it will sense is too much current. A4, A5, and here A514, A512. Why the screen is switching off? The backlight. That circuit monitoring the current probably sensing something more. No, we don't have a feedback pin on this chip. No. Only this resistor. And also for the camera, it's monitoring the current, 60 milliamps. Or, you know what? I think I know what's the problem. This wire resistance probably is higher compared with the one from the circuit, which has 0.0 something. And obviously, the chip is comparing B plus. Yeah, no, we can't do it. We can't do it on this way with the wire. No. Because what will happen? The chip is a supply, yeah. If we short this to B plus, yeah. If we short this to B plus, probably the MOSFET has lower resistance compared with my wire. And on that point, a potential voltage, it will increase across the resistor. Yeah. So I think we need a shorter wire. That's what I think. Okay, let me short this wire quickly. So now we have a shorter wire. Let's see. Pressing the power button. And we have picture. Backlight actually. We still have backlight. And it's working, right? Yeah, it's not shutting down anymore. It is. It's shutting down. Hmm? What is this? Wait, why is doing this? You think the current is changing? Now it's working. You think actually now the current is low? And if I close it, actually it's possible to be the screen ribbon cable. Check here. You know what? I want to check the current with the screen on. I want to check the current, but how can I do it? Because the wire is soldered and it's switching off. And now it's on. Wait, do you think actually it's a lead sensor issue? No. So what is this? What is the problem? It's switching off. Why? We didn't touch the screen. I mean, yeah, it is warm here. This is a hard job. It's switching off by itself. But why? I check here. I mean, I'm moving the screen more forward, and it's starting again. And it's switching off. Now it's working again. And it's switching off. And if I push the screen more, it's starting again. Do you think actually? No way, no way, no way. Check here, yeah. Yeah, moving the cable. Check here, moving the cable. That's crazy. No, it's not the connector, and it's not the cable here. Check here. No, no. It's not the. No, it's here. It's here. The cable is dodgy there. And that's the reason why this screen is taking 500 milliamps. That means it's shorted. It's something is shorted there. Otherwise, I cannot explain. Check there. Huh? Check there. Oh, that's crazy. And I worked like 2 hours on this one already. Okay, what we can do with the cable? I mean, I can't see anything here. I know what you think. Check with a different screen, and yeah, but this screen is mad expensive. You know, you cannot just buy a screen Let's check to see if it's working. You know, you can't. It's very expensive. Don't try to explain you. You have to be 100% sure you want a screen. Yeah, probably shorting something to the shield. We have that metal shield there. Yeah, the battery is unplugged, so we are safe. I mean, I'm curious what you will do in a case like this. Order another screen. Yeah, but we are ordering another screen, but we lost the money, right? You can't charge money for 2 hours of searching. Because, yeah. We have to take the risk. And the customer will say, okay, buy the screen and replace it and I will pay. And you buy the screen and it's not working. And you lose the money for the screen. In the best case scenario, maybe the seller can accept your return, but maybe not. Usually they don't accept returns because you were wrong. What is that wire? Don't tell me I broke that wire. Yeah, not every job is like, simple. And I was thinking, backlight. This will be a nice, video, end of the day video. Easy job, easy pizza. No easy pizza this time. No easy pizza. Nah. No easy pizza. And it's working, but it was working even before. It's about how long it will be. No, it's going on standby. No, it's fine. No, that's okay. That's normal. How long it will? If I move the cable, yeah, it's still dodgy. Yeah, still dodgy. Okay, I managed to pull the cable out. This can be lifted a little bit and you can pull the cable out. Let's open the cable. I mean, here we have two different cables, and I'm assuming one is from the webcam and one is from the screen. You know what? I think there's no way I cut these wires. I need a ground wire. Yeah, but actually we have one more there. Okay, I can cut this down. So which is the wire? I mean, I'm moving the wires, but no, nothing. No, nothing. You think probably it was one shorted? Not sure if you can see. But check here, I'm moving. Yeah. Okay. So which one it is? Don't tell me it's actually the webcam cable. Do you think it's the webcam cable? Because I think the power from the webcam is read also. And obviously, if any value of that current sensor is not good, it will cut the brightness down, the inverter voltage. You know what can be the webcam? Hmm. Nah, no, must be the screen. You know what? I can't figure it out which is the wire, so I will start fixing the wires. Yeah, every broken wire. Perfect. Perfect. I think I sold the raw wires. I found 3 which was broken. You know, to separate the solders. Good. What is this? Okay, we didn't find the problem yet. Actually, I want to see the screen. There. No freaking way. This is insane. I work for nothing. Actually, check here, yeah? This is capacitive. So if I'm trying to move it with something else, nothing it will happen, you see? Nah. But if I came close with the finger, yeah, check there, yeah? So this is kind of capacitive, yeah? It's not like like a mechanical thingy. It's actually because I'm coming close with the fingers. So it's one wire which probably is interrupted, and probably is the backlight on or the dim. Okay, just to understand the fault, yeah? So check here. Yeah, so this is not like an interrupted wire, at least not here. So what you see here is one input from the inverter, either the backlight on or the dim, the PWM dim. This wire is like a floating gate of a MOSFET from the inverter. So here is like capacitive trigger. You know what I mean? So holding the wire, we have backlight. But if I try to move the wire, yeah, you can see it's not like the wire is interrupted. No. It is interrupted because that's a floating gate on the inverter, but it's from here to the board. So that's the problem with this laptop. Check here. You can see? Yeah, that's the problem. And if I move it, I can move it. Nothing it will happen. I mean, probably on some point, if I move the wire close to the other wires, it will happen something. Yeah, but looks like nothing happened. So that's the problem with the backlight. Now, I know this wire is going to my inverter. So I have to find where the wire is going to the connector, because here is the problem. Either actually the wire itself it's floating. So obviously if I'm touching here the pins, I should have exactly the same result. So I'm gonna try to tap the wire and see if it's interrupted anywhere. Yeah, probably here. Check here. Check here. Here. Must be here. I'm just hoping it's not capacitive. It's capacitive. It's not a connector. Here. Let's see where the blue wire is going. So the blue wire is going exactly here. Check here. 1, 2, 3, 4, 5, 6, 7. 7? Wait. 1, 2, 3, 4, 4, 5, 6, 7. 7. Seven, it's LCD GPIO. This is on data line. Huh? Okay, I'm confused. I'm not convinced. A data line can trigger a fault like this, but I'm gonna check. So pin number 7. Pin number 7, which is this one, with the blue wire. I'll freaking make a hole on this wire. And it's not beeping. No, it's not beeping. It's not beeping. Maybe it's beeping with different one? No, it's not beeping. So this is the problem. No, it's not beeping with any pin from the. It's beeping. Now it's beeping. Same story with this wire. We'll check the voltage. So check how the screen is doing with one probe on that wire. And the voltage is like 1.5, 1.6. Check here. You can see? And I have the probe on that blue wire. 0.2 volts. Okay, the next step, I will check on the connector. Okay, I unplugged the battery, so I'm trying to beep this wire exactly on the board. So we are beeping the wire here. And it's not beeping. No. Here is beeping. That's crazy. So the blue wire is beeping here. What is this? How? Here. What pin is that? 8, 9. It's pin number 9. Pin number 9, which is Backlight PWM. Ha ha. Can't believe that's crazy. Okay, let me power on the laptop. Let's check that pin. So the laptop is on. The laptop is on. And this pin, I can't believe. This pin has 1.4 volts. This pin is floating. It shows like 1.5 volts, but that's not real. And I will show you why it's not real. Why that 1.4 volts is not real? So check here, yeah? I can't see anything. No, I can't see. Because when I'm touching with the probe, the brightness is changing. The brightness is changing. Can't believe. That's crazy. Such a long job. What is the solution? Very simple. Yeah, now we can achieve our goal to deliver a Dodgy job. So this pin, it's actually floating on the board. You understand? On the board. This is floating on the board. So it's not connected anywhere. So what is the solution? The solution is, let's see what voltages do we have there. 3 VS cam. I don't know if this is present. If not, I'm just, I will use a wire to 3.3 and end of story. You know what I mean? Perfect. So we got 3 volts. Let's see if it's working. Now is the moment. Good. Pressing the power button. We have backlight. That's good. That's good. You think actually the problem with the current is related with this? We're gonna take the wire out. Yeah, no issue, no problem, no, nothing. Okay, good. Let's take the wire, the one I bypassed that chip. So you think if I take this wire out, now it will work? Let's see. Or if it's not working, how much current is taking now? We have 2 different faults, or actually it was only one. So plug in the battery, pressing the power button. Now, are 2 different faults. Are 2 different faults. Are 2 different faults. Power supply, let's see what current is taking. $430 milliamps. No. Are 2 different faults. No. 2 different faults, yeah? 2 different faults. Otherwise, you can't, I can't explain why I'm working over 2 hours on this job. Over 2 hours on this job. No. Has no explanation. No, you can't explain something like that. No. Yeah, so are 2 different faults. Not even sure if it's worth. I mean, what you can do? So first you have a screen issue. It's taking huge amount of current. The second, you have a board issue. That track is floating and is supposed to come from the EC chip. And if we are start digging in this fault, because I dig in the past many times, we will end up with a good track, but probably a dead pin on the EC chip, or who knows. But something wrong with the EC chip. And the EC chip cannot be replaced. This is a MEC chip. I can't program a MEC chip. It's not even worth. So the laptop is working fine. We cannot adjust the backlight, that's right. But, you know, no problem, no issues. Check here. Solid, huh? That's crazy. I think this fault is like kind of unique. It's not unique in itself, because I seen before like floating wires. But I never like, you remember how we start? We start like, okay, it's working like that for a while. Then I have to move the screen, it's working for a while, then it stop. Then I move the screen, it's working for a while, then stop. This was that capacitive thing, because the wire was floating. And every time I was moving the screen, probably that wire got charged somehow. This is like over my understanding power. This was a sick, crazy fault. But anyway, this laptop is repaired. And, you know, on the beginning, it was looking such a easy and pleasant Dodgy job. You remember backlight? Like, I mean, like a wire, like a fuse, like a what? You know, shorting the backlight or the dim to the 3.3. But this was crazy. It was insane. And from the beginning, you know, I got like confused by the customer, of course, because he soldered this connector. I said, okay, that's the. I didn't even see this one. I was like, okay, that's the one. Yeah, we have proper 2 Dodgy wires, so we deliver what we, you know, what we said on the beginning. Anyway, I'm gonna stop now. Okay, I will put back the wires, you know, some tape, and put it all back together. That's not a problem. Yeah, we have 2 Dodgy wires there, but it is what it is. I will say I can't see other better solution compared with those 2 wires. I can't see. You have a faulty screen and a faulty board. Yeah. Okay. Thank you for watching. You know, like, subscribe if you like the video, and see you on the next one. Hopefully with a more easy job. Bye. Hey, if you find my content being helpful, don't forget you can support this channel by pressing the join button, and you can get instantly access to our members-only cool collection and Discord private channels for support with your repairs. Also, you can have a look on our United Kingdom eBay, where you can find some cool and unique products, United States eBay store, or our Patreon page. Thank you.